Okay, everyone. So we just talked about equilibrium in our last video. Now we need to discuss what affects equilibrium. So we were discussing earlier how an equilibrium means that the reactants and then the products are in a reaction, which happens to be a reversible reaction. Your reactant becomes product, and then product can go back to the reaction. It's just that the rate of the reaction in both the direction becomes equal when you're at equilibrium. Equilibrium does not mean that you have equal ratios or equal amount of product and reactant at the end of the reaction or at equilibrium, basically. The how much more product and reactant, how much more reactant you would have in the reaction depends on the K value. That's what we discussed in the last video. So what we're going to discuss now is how we can affect the equilibrium. Okay, so there are two things we're going to be discussing here. One is concentration, and the other one is temperature. These are the two factors which can affect the equilibrium, where the equilibrium lies in a reaction. Okay, so if we were to write down an actual reaction, let's take an example of nitrogen gas reacting with hydrogen gas and making ammonia. And if you see this reaction is not balanced right now, if we were to balance it, we can just put a 2 here and then a 3 here. And now you see that the reaction is balanced. Now, this is actually a very important reaction that happens in industry because this makes ammonia, and ammonia is used in fertilizer. So there's a lot of energy actually spent to just do this reaction. It's very hard to convert nitrogen and hydrogen from the air and change it to ammonia, which is the actual useful form of nitrogen. And all plants need nitrogen, and we need nitrogen. We get it from the plants, animals get it from the plants, but plants are getting it basically from the ammonia. And that ammonia is either, made through bacteria in the soil, or we add the fertilizers, which add the ammonia to the soil, and thus the plants take it from there. So this is a very important reaction, and this reaction has an issue. The issue is that this reaction wants to. So this reaction basically produces heat. So if something is producing heat, what would you call this reaction? This is an exothermic reaction because this gives off heat. Okay. Now, since this is an equilibrium reaction, there are only two variables that we can control to affect the equilibrium, or where the equilibrium is going to lie. So if you were working in industry and you were producing ammonia, then your profits will depend on how much ammonia you can make. The more ammonia you can produce, better, more profitable that's going to be. So as a chemist, as a scientist, you would want to make as much ammonia as you can. You want to find perfect conditions in which you make maximum ammonia. So let's first talk about concentration. If you were to add more nitrogen or hydrogen gas into the reaction, it will shift the reaction, it will shift the equilibrium to the right. So the rate of the reaction to the right will go up. What does that mean? If I add more nitrogen and hydrogen, if the reaction was already at equilibrium, you just disturbed the equilibrium. And guys, this is actually another topic of principle, which is called the Chatelier's principle. And again, the guy, Le Chatelier, gave us this uh, idea, this principle, that if you disturb the equilibrium, then the equilibrium is going to shift in such a way so that it gets back to that balance where it was earlier before you made the change. So if you were to add or remove the reactant, it's going to behave one way. If you add or remove the product, it's going to react another way. So what it's going to do, guys, if you add more nitrogen, which happens to be the reactant, if I add nitrogen, then you see how if the reaction was already at equilibrium, you add nitrogen, that disturbs the equilibrium. Now the reaction is going to go more to the right, and it's going to try to convert this nitrogen so that the nitrogen concentration goes down to what it should be at equilibrium. So if you add reactant, so in this case, if you add nitrogen, or basically if you add reactant, you the reaction would want to go to the right. Okay, so reaction equilibrium shifts to the right so that you can get rid of the nitrogen. You get rid of N2 and you make more ammonia. So if you're interested in making more ammonia, add more reactants like nitrogen and hydrogen. This will shift the equilibrium to the right to get rid of nitrogen and hydrogen from the system and make more ammonia. Okay, so that's favorable if your goal is to make more ammonia. Now, if your goal is indeed to make more ammonia, then maybe remove the product that you're making. So you see how if you remove NH3 from the reaction, again you disturb the equilibrium. So if you're removing the product, that will also shift the equilibrium to the right because the reaction is thinking we don't have ammonia anymore. So we because the ammonia was removed, so let's make more ammonia. And for that, again, the equilibrium will shift to the right and you'll end up making more ammonia. So if you really want to make more ammonia, just add more reactants and then keep getting rid of the ammonia that you're making. This will keep driving the reaction to the right and you'll make more ammonia. Okay. Now, um, and again, if you're doing the opposite, if you're removing the reactants, the reaction will go to the left. If you are adding ammonia, if you're adding more product, then also the reaction will go to the left. Okay. Now, if you see in this particular reaction, this reaction is exothermic. So there is heat being produced here. Okay. So think of heat as a product in this reaction. Why is it a product? Because you wrote it on the right-hand side. Because this reaction produces heat. It's an exothermic reaction. So you can say that exothermic reactions, since you produce heat, think of heat as your product. So think of temperature and heat. If you were to raise the temperature of this reaction, what is going to happen to this reaction? Again, think of the Le-Chatelier's principle. If the reaction is actually producing heat, if you treat heat as a product and you raise the temperature, you see how that's going to go against making more ammonia. This will shift the equilibrium to the left-hand side. So if the reaction is making heat, and on top of that, you raise the temperature, then the reaction does not want to make more ammonia and more heat. It will instead go to the left so that it gets rid of the heat instead. Okay? So just like how you are playing with the concentration, you can play with the temperature as well to find again a balance or optimal conditions in which you make more products. So if the reaction is exothermic, heat is the product. So if you add more heat, the reaction will shift to the left. If the reaction is endothermic, so if you had a reaction where you had, for example, chemical A and B producing chemical C and D, and in this reaction, the energy was supposed to be on the reactant side, meaning energy was getting confused. I'm sorry, energy was getting consumed. So the energy is on the left. Energy is getting consumed. So this is an endothermic reaction. So what is this saying? This is saying that this reaction actually absorbs heat. Just to be consistent, let me put the word heat here. Okay, so this reaction absorbs the heat, so it's an endothermic reaction. So in this case, if you were to add more heat, then it's like saying you're adding more reactant. And remember, if you add more reactant, then Le-Chatelier's principle suggests that the reaction wants to get rid of the heat, so the reaction will now shift to the right. So if you want to make more C and D and it's an endothermic reaction, then adding heat is a good idea because that will shift the reaction to the right. Okay. So I again hope this makes sense. Okay, all right, that'll be it for this video.